Today we're going to look at the chain rule for differentiation, a very useful rule. You use it a lot in your A-level studies. It takes a bit of getting used to. You do need to do quite a few examples before it becomes natural to you, but I'm sure it soon will. So we use it when we've got a function of a function. So we've got one function inside another, in other words. So here's an example of one where we've got the function 2x plus 1 inside another function, which is 4 times the thing inside cubed. So we're going to split that into two separate functions. So we're going to say we have y equals 4 lots of t cubed, okay, where t is 2x plus 1. Okay, so if we put the t inside to the other function, we'd have what we started with. So then we're going to differentiate each of those. So dy by dt is 12t squared, and dt by dx is 2. The thing that we rely on with the chain rule is the fact that if we have dy by dt and we multiply it by dt by dx, although it's not a fraction, it does actually act like a fraction, and that allows us to multiply those two things and give us dy by dx. Okay, so that is the rule that we're going to be using here. The y of it is quite complicated to understand. There is a separate video that you can see whereby you can follow the proof, but it's quite complicated. Anyway, we're going to use that fact. So if we want to find dy by dx over here, we're going to multiply our dy by dt, 12t squared, by our dt by dx, which is 2. So we've got 24t squared. We've got to replace the t, so we've got 24 lots of 2x plus 1 squared. Okay, and that's it. Okay, so this first one we're going to write as y equals 3t to the power of 6, where t is 1 minus x squared. Differentiate both of those, so we've got dy by dt is 18t to the 5, and dt by dx is minus 2x. Putting the two together to give us dy by dx, we've got minus 2 times 18 is minus 36, x t to the 5. So if we replace our t, we've got minus 36x, 1 minus x squared to the 5. This one we need to write first as 3x squared plus 4 to the minus 1. And then we can split it into our two functions. Y is t to the minus 1, where t is 3x squared plus 4. So dy by dt is minus t to the minus 2, and dt by dx is 6x. So putting the two together to give us dy by dx, we've got minus 6x, got the minus from the first one, and it's multiplied by t to the minus 2, so I'm going to write that as t squared on the bottom of the fraction. So we've got minus 6x over 3x squared plus 4, which was what t was, squared. Let's try some with sine and cosine. You know how to differentiate those now, so we'll try those. So here we've got y equals sine of a function that we're going to call t. So y is sine t, where t is 4x plus 10. Dy by dt is cosine of t, and dt by dx is 4. Putting them together to get dy by dx, we've got 4 cos t. I'm going to go straight for putting that in as cosine of 4x plus 10. After a while, you can start, if they're not too difficult, you can start to leave out the t stage, but for the moment we're going to stick with it, because I think while you're learning this, it's a useful technique. Okay, so this one over here, we've got y is cosine of t, where t is x squared plus 1. Dy by dt is minus sine t, and dt by dx is 2x. Combining the two, we've got dy by dx is minus 2x sine t minus 2x sine x squared plus 1. Okay. Now I've put these last two together so that you can compare the differences between them. Or you can compare them, I don't need to see the differences. Right, so the first one is probably the easier of the two. We'd say y is sine of t, where t is x squared. Dy by dt is cos t, and dt by dx is 2x. Put the two together. Whoops, I've written dx there. Be careful not to do that. So dy by dx is going to be 2x cos t, or 2x cos x squared. Second one, what sine squared x means is sine of x all squared. So this time we've got y equals t squared, where t is sine x. So it's not really harder, it's just that you've got to realise that's what sine squared x means. So dy by dt is 2t, and dt by dx is cos x. Combining the two to give us dy by dx, we've got 2t, and t is sine x cos x. And once you've learnt your double angle formulae, you'll know that that is sine of 2x.